Okay, thank you. Yep, I'm Director of Precision Gauges working out of Providence, Rhode Island. As Tom said, I've been with the company for a long time, so if you have any questions about snap gauges or any type of dimensional measuring application, feel free to contact us and we'll get you the answers. And again, if you have any questions during the presentation, you can use that chat feature and I'll respond either during today's webinar, or we can set up a response and I'll send you an email with a specific question. So let's get going. So today we're going to have a little refresher about measuring versus gauging, because there is a little difference, and snap gauges are a way of improving your measuring process. And specifically, we're going to talk about the number of different snap gauges that Mahr offers, the 300P series and our 840 series of snap gauges. And then we'll talk about a couple of tips for good gauging. Now, when you think about if you have a shaft or a ball, now how many ways do you think that you could measure a simple outside diameter? Well, there's probably a ton of them out there. And you can go anywhere from a surface plate with a test indicator, a stand, and a V-block. You can use micrometers or calipers. You might have a special built gauging fixture to do that. You can do it with a snap gauge, a bench ID or OD gauge with adjustable contacts. You can go all the way up to a CMM if you wanted to, or a simple bench stand, probe, and amplifier. Or you can get probably into a big automatic measuring system to do that. But there's lots of different questions that one would ask, and you could probably narrow your way or funnel your way down to one of these solutions. They're all good, and they're all meant to support a specific application or need. But today we're going to talk about the snap gauge as one of these solutions, because it can be a very viable and useful solution for measuring an OD. Now, myself, just like everybody else, I can say measurement and I can say gauging, and we're kind of saying the same thing, but really there's a difference between those two ways of getting a dimension. So I like to think of it as a measurement as a process of determining a dimension of a part by comparison to a standard, where gauging is the process of determining whether the dimension of the part is larger or smaller than the standard. So there's two different things going on there. One has the reference or the standard built into it, and the other one has the reference or standard external. So measuring instruments, they have the standard built into them. Micrometers, scales, and calipers, they are a system that has the standards built in. They tend to be relatively slow and require more skill for accurate measurements, because you have to align the caliper or align the scale to the part. But with a good operator, you can get some pretty good results. These are variable gauges that have, or measuring instruments that have lots of measuring range, lots of versatility, but they tend to be slower and not the most accurate types of measuring instruments out there. Like I said, gauging is the process of determining whether the dimension is smaller or larger than a standard. So these have external standards. They tend to be a lot faster, more accurate, and more dedicated to the task. And there's a subset of variable gauges, and we'll just take a quick look at those. Fixed gauges, these are made to one dimension. These are our masters, master snap gauges, go, no-go gauges, and so forth. And they just kind of tell you whether the part is good or bad. You don't get any deviations of how good or how bad. You just know that the part is good or bad. There's no information about the part form. It's the fastest process. It's good for one size. Sometimes there's questions about how, if you use a little force on that master and makes it fit, is that really good or not? So, there's some human error with that. It's probably a pretty low initial investment of buying just a master for a part, but you have to maintain that master, store it, get it recertified and so forth, so you can get some added cost over the years. And then usually you'll need two masters, one for the min and for the max for that size being checked. But this has been, this is what started the Industrial Revolution, is these fixed master, fixed gauging systems. Then we move up to adjustable variable gauges, like our adjustable bore gauges and so forth. And they can be adjusted to a specific size, but they have a limited measuring range. So now you can actually get and record the actual deviations of the part. But typically, the operator has to sweep the part to capture the size, which takes some operator skill, but with practice and experience, this can be a fast, easy way to measure a whole variety of different parts. You still need a master, required for each size, a nominal master. It's a little bit larger investment, but these gauges can last for decades when they're maintained. And by using the variable data, you can learn about form, process trends, and diagnose manufacturing issues. And there's a whole family of different types of adjustable variable gauges out there. Adjustable bore gauges, tri-bore gauges, ID/OD measuring gauges. These are all adjustable gauges. You fix them to a specific size, set them against a master, and now we have very limited measuring range to look for the part deviation. Now you can take that variable gauge and improve it a little bit by adding a backstop to it. So you have an adjustable variable gauge with a reference. Now these types of gauges with a reference again indicate how much the part deviates from the standard. Again, they're adjusted to a specific size. They incorporate a reference stop to help position or lock the part into a repeatable place for measurement. Therefore, once you snap that gauge on or lock it in position, it's ready to make that measurement and it'll give you a good repeatable reading. So there's very little operator skill. It's very fast, very easy to use. Again, just like a variable gauge, it has adjustable range, but a very short measuring range, giving you the actual deviations for your process control measurements. You require a master. These are relatively, they're not expensive, but they're an investment that you have to make. And again, using that data, you can learn about the form, process trends, and diagnose manufacturing issues. And there's lots of variable gauges with references. There's snap gauges. There's these bench ID/OD gauges. And any bench stand will also benefit with the use of a backstop for a reference, because it really positions the part in a repeatable position, which greatly improves repeatability of the system. But the best type of variable gauge are these fixed variable gauges like air gauging, fixed plug gauging. These are the most accurate. They provide actual deviations, no operator influence. You can learn about the form, process trends, and so forth. They're the fastest and easiest to use with the best performance, but they are limited to one measuring size. So the initial investment is pretty large, but again, these can last a long time, and you need a master for them. But we're gonna talk today about snap gauges with backstops, and these are variable gauges for most OD applications. They're a step up from other measuring systems, and they're probably the fastest and easiest to use of the variable type gauges. Again, they provide the actual deviations. You can learn about form. They're very easy to use, and I think they're a good value for the investment. For a snap gauge, you need the snap gauge, you need a master, and then you're ready to start making your measurements. So these instruments are, you think about good, better, best. How do I get the best performance for my application? And over the years, tolerances have gotten tighter and tighter. Micrometers may have been a good way of measuring parts at the point of manufacture for many years, but all of a sudden the tolerances get tighter. And Snapgate and micrometers, like I said, they have good performance. They're a measuring instrument, but they're subject to human errors in terms of screwing the contact to the part, aligning it, getting the right force, and so forth. Plus, they're slow to use. With a snap gauge, you set it to a specific size. It's dedicated to that. There's no operator influence. And what do? You improve the whole measuring process. Your uncertainty of measurement gets smaller and smaller because you're using a gauge that's more dedicated to the task. So that's the whole purpose of looking at the application, looking at the tolerances, and there's points where you can move along that variable gauge chain to get better performance and value for the gauge. Snap gauges are a step up from normal micrometers out on the shop floor. Faster, easier to use, and better performance. Now, snap gauges, it's like we talked about fixed gauges. Well, fixed gauges you have to maintain, certify, and store. With snap gauges, they have the advantage of lots of cost savings. You can measure different sizes. You only need one master per size, and you get a lot of better performance. You get away again from that human error with using a snap gauge. Now, Mahr sells a number of different snap gauges. Well, let me before I go any further, I don't know if I had any questions yet or not, but if there's anything out there, let me know and I can answer your questions. But today, Mahr offers a number of different snap gauges. We have two families of snap gauges: the 300P series and our 840 series. And you'll see that the 300P is a very robust, made for real tough industry applications. The 840 series is a little more sensitive, but it allows for better performance at the point of manufacture. The 300P series is usually purchased as a complete assembly, but it can be modified and configured in Providence with specials. We can do larger sizes. Performance levels are usually down to the 50 millionth area, and you can get these with dial, digital indicators, or even LVDTs if required. The 840 series is a configurable by the user type. They're more standard products. We don't do too much in the way of modifications, but you can buy the snap gauge, you buy the indicator you want. You can get performance and repeatability down to 20 microinches with this type of snap gauges. And these again start from 0 inches and can go up to typically into the 4 to 5 inch range is the typical application size. Now let's talk about the 300P series for a minute. These have our patented channel lock for anvil parallelism. That's an important part of any snap gauge. Is you want to make sure that the anvils are parallel, so you don't get any errors and by the different size and measuring different areas on the contact. So it's important to have parallel contacts. These are very rugged design. Again, these are meant to be used out on the shop floor at the point of manufacture. These comes in a variety of sizes, anvils, indicators, and accessories, and standard sizes up to 9 inches, but we've made snap gauges larger than 30 inches if required. The 300P series, the lower anvil is an integral part of the frame itself, and the size is set by adjusting of the channel lock mechanism, the frame part, or the right side of the indicator sensitive contact, all travel as a unit within the channel lock. So as that's moved up and down, and then it's drawn back into the channel lock, it realigns itself, and we maintain the parallelism. The anvils are wider than the frame, so we have a large contact area, which helps in reducing wear. It has a big reference anvil in the back, so it can really snap onto the part when we're making measurements. And with all gauges, you want to have some type of heat insulation so that the user doesn't influence the measuring process. And just take a quick look at what a snap gauge consists of. You have a frame. Always look at, most gauges look like a C, the letter C. They have a reference contact, a backstop, and a measuring or a sensitive contact forming the C. If you look at any gauges, as long as you have those three parts, you're going to have a pretty good measuring system. But there's adjustments on the snap gauge for moving the sensitive contact up and down, locking it in position. You have an adjustable reference backstop, and you have a fixed reference, which is your measuring anvil. All these anvils are carbide for long wear, again, meant to be used hundreds of thousands of times measuring a part. These snap gauges can come in with dial indicators, digital comparator, digital indicators. We make large special ones, as I noted. So all these gauges are fully adjustable with the positive position for locking at any point within its measuring range. The sensitive contact has a travel of about 20,000. So most tolerances for this type of gauge are much less than that. And we can get a whole wide selection of anvils, carbide, blade, ball contacts, and more. And specials can include larger sizes, extended travel, and modified anvils. But just looking at the different types of contacts are available. For this is an example of cross section of some diameters where we can put chamfers on the left side there to ensure that we can get close to a radius of a part or within a groove. We can have side relief like you see on the right side here, on one side or the other. If we're trying to measure over a specific area, we can make anvils to get into those types of conditions. We can make narrow anvils. We could put ball contacts. We can make ball or line contacts like cylinder contacts or two-cylinder contacts for doing pitch diameters on certain types of gears and so forth. So lots of capabilities of making custom snap gauges for an application. There's our carbide wires on the left side there. Have special backstops sometimes to align the part. Again, all configurable things from Mahr. We even have snap gauges that have extended range. So we can have a snap gauge that has if your part has larger tolerances and you want to measure within a half-inch measuring range, we can make snap gauges that have a half-inch retraction, and you can measure anywhere within that half-inch range once the gauge is set to its specific size. And here's an example of some of the larger ones we've done where you can basically get up to 30, 40 inches with a snap gauge. They can be electronic, allowing for large diameter shafts to be measured, or they can be of more portable size with handles to make them easier to use. So let's take a look at the 840 series. This is the little higher precision snap gauges, and these come in a couple of different series. These are rugged forged steel frames with heat insulators. The measuring spindle is mounted on a long guideway with a lever-controlled retraction. So these have retraction built into them. The anvil spindle or the reference anvil can easily be adjusted with a fine adjustment screw, and these use a constant measuring force because the built-in spring eliminates any user influence. So you can see there's a couple of different there's 4 different models here being used with dial comparators. And I think dial comparators are a lost art. In terms of comparators, they provide short range but very high resolution, which is a perfect match for a snap gauge. Again, we have lots of variable range but very limited uh, measuring range. So very often people will put a half-inch digital indicator or dial indicator on a gauge like this, when really you only need a couple of thousandths of measuring range within your indicator, and now you can get a higher resolution. We'll look at our standard snap gauges. These come up to an 8-inch size. They have this is kind of an opposite to the 300p. These have an adjustable reference anvil by the screw knob on the bottom right there. The sensitive anvil is on the left side. This uses a right angle movement to the indicator, but these are also adjustable by the user, where you can put the indicator straight in line with the anvil if you wanted to, and still have the retractable contact. The reference anvil is that little button on the left side there, so we're still getting the 3-point or C-frame type measurement with this type of snap gauge. And then there's different variations of that. Just like the 300p had different anvils, the 840 series has interchangeable contacts. So you can get some very small anvils. These have a tapered hole in there that mounts these interchangeable anvils, and you can get different sizes, lengths, and so forth, where all kinds of measuring problems can be solved with a standard range of contacts. Another type of 840 is one that has a screw-in contact. So these have a metric 2.5 connection thread for mounting interchangeable contacts. And again, in this type of gauge, you can use ball contacts or point contacts or special contacts for doing threads and so forth. And you can now make this into a thread measuring system, doing pitch diameters or over thread dimensions. And here's just an example of the type of different contacts that you can get. You can get flat contacts, ball contacts, blade contacts, offset contacts. A whole family of different contacts are available to measure grooves or lands or different parts on the OD of maybe a shaft or any part that you have. We also make a snap gauge that measures the tooth spacing on spur gears. This is very popular in the gear industry, and another application using different contacts on the standard 840 frame to allow you to measure the spacing of gear teeth. So basically what this measures, this is the WK format of measuring tooth spacing. It's for diameters of small hubs, shoulders on shafts, groove widths. This WK is a indirect reference free determination of tooth thickness on spur gears. We also have a bench-mounted snap gauge, or our 852 series, and this is again a snap gauge that's mounted to a base. It has the adjustable anvil in the back, a reference anvil that's adjustable to various sizes. So this is a very nice gauge when you don't want to bring the gauge to the part, but you want to bring the part to the gauge. So this is ideal for smaller parts where there might be hundreds of parts to be measured. It's very easy to to bring that part to the gauge, snap it in position. It does have a retractable contact. It's easily adjusted. You can adjust the angle for use. And it's a nice bench gauge for very small, sensitive parts to measure. And we can also do custom applications, taking the 840F, adjusting or adding special indicators, special contacts, measuring, in this case, a pitch diameter here. Again, you can contact Mahr, and we have the application to support to help you with your snap gauges. So, like I mentioned, snap gauges are a fast precision measurement of ODs on the shop floor. They can be portable or bench mounted, wide variety of applications. Typical tolerances are plus or minus 1,000th or better. They're versatile for a wide range of sizes. The nice thing about these variable snap gauges with the fixed reference is that there's very little operator influence, and they provide long life. We've seen these gauges last 30, 40 years. They come back for a new set of anvils, and they're ready to go again. So, but these gauges are just like any other gauging system that's out there. You have to ask some questions of what am I going to do? So we're always going to ask, as being part of the selection, is what's the part tolerance? Where is that check going to be made? What master do we want and class that goes along with it? We're going to help you choose the right accessories. It's always good to have a clearly defined part print with the application. And without that information, we could have some delays, but it's important to provide the right information as part of any request. How do you make that measurement better? Well, during the day, these gauges are very stable, but it's always a good practice to verify the zero or the master position during the process, whether it be on an hourly basis or maybe every half hour. Just put that master back in there to verify that nothing has shifted during the operation. It's especially critical in the tolerances get tighter. It's good to verify the zero location. It's always good, you're working in the shop floor to keep that master, the workpiece, and the gauge at the same temperature. Try to keep everything, because they are comparative gauges. If everything's at the same temperature, there could be changes in temperature, but because they are comparing everything at the same materials and so forth, you don't have to worry that much about temperature variation. And dirt is probably up there in terms of environmental issues causing or being the enemy of precision measurement. Wipe the dirt from the part, keep the gauge clean, keep the environment clean, keep your fingers clean. That will help and go a long way for making reliable measurements. So why Mahr for your variable gauging needs? We have the expertise, we have the partners in the field that can help you with your application. We can support with application know-how. Mahr builds the accuracy into all their gauging. And we know accuracy since we not only make the gauging, but we also make the masters, and we make the equipment to measure the masters. So we know measurement and we know accuracy. So in summary, I think we talked about the versatility of measuring OD with a wide range of different products. Snap gauges are an excellent way of doing that because of their superior accuracy. They're durable, they have a robust design, they're simple and easy to use, they meet all those typical on the shop floor OD gauging needs. Modifications are available for doing special applications, and snap gauges can be a bench or a portable type of application.